We want to have now a look at justifying the pattern. So justifying whether it's a curve, a nonlinear, or a straight line linear pattern. So think about a slide. For linear patterns, think about the stairs going up the slide. You're climbing up steps which are the same distance apart. Both the same distance in terms of the horizontal distance and the vertical distance and the angular distance. So all the distances between the steps are the same. That's what makes it into a linear pattern. So the slope is a constant slope, constant rate. Whereas for nonlinear patterns, it's the other side of the slide. As you go down your slide, you'll notice that the slope is changing. Some parts of that slide are steeper than others, so you go faster. Some of them are shallower or flatter, and so you don't go as fast down the slide. And that's how we can justify that something's a nonlinear slope. So if we have a look at this graph here, this is looking at the temperature of lava versus the time since an eruption. And what we want to do is label the steepest and flattest parts of the graph. So think about it in terms of you're going down the slide, which parts would you go fastest down? And that's the part up the top. So that part at the top is the steepest. Whereas, which is the flattest time? Where do you slow down if you're sliding down? That's going to be down the bottom. So the bottom part there is the flattest. So we need to be able to identify what is a steep graph and what is a flat part of the graph by thinking about that gradient.